Hi everybody, we are on What is SOHCAHTOA? Chapter 9, Worksheet 2. Let's get started. So, SOHCAHTOA, you will hear this often. It actually stands for something. It stands for the trigonometric ratios. So here they are. So stands for sine of theta. That's just like an x, but it's always meant for an angle, but it's pronounced theta, is equal to the opposite, that's where the O comes from, over the hypotenuse. Cosine theta, the C, is equal to the adjacent over the hypotenuse, and tangent theta is equal to the opposite over the adjacent. Really quick, I want to remind you that these ratios only work in right triangles. Just like the Pythagorean theorem only worked in right triangles, the trigonometric ratios only work in right triangles. Okay, so to find the opposite, adjacent, and the hypotenuse, it depends on what angle you're dealing with. So the hypotenuse, we can always find it. It's right here. Okay. But in order to find the opposite and the adjacent, those sides always depend on the reference angle, which basically just means the one that you're talking about. And the hypotenuse is always located across from the right angle. We know that one. So it's the angle, which I've indicated here. So I'm putting my theta there. The opposite is literally just across from it. So it would go across. So the opposite is BC, side BC. The adjacent is the one next to it. If you see, the angle is made up of the hypotenuse and the adjacent side. It's the adjacent means next to. So it's this one next to. Okay. All right, now I can switch it up and I can use C as my reference angle. So for C, my hypotenuse doesn't change, but my opposite does. It's across. So that's AB. And then my adjacent is the side touching the angle right here, adjacent, BC. All right, so let's do some examples with numbers. So if I'm looking for sine A, again, I'm going to use SOHCAHTOA to help me out. Sine is the opposite over the hypotenuse. So first of all, I need to locate my OH and A. So I go to A. There's my hypotenuse across from the right angle. My opposite is across from angle A, and my adjacent is next to it. So now I can simply fill this stuff out quite easily. So sine is opposite over hypotenuse, so that would be 4 over 5. Cosine is adjacent over hypotenuse, so 3 over 5. And tangent is OA, so opposite over adjacent, 4 over 3. For sine C, cosine C, and tan C, I'm switching it up. I now have C as my reference angle. Again, the hypotenuse is going to stay the same. The hypotenuse does not change. But the opposite is now 3, and the adjacent is now 4 because my reference angle changed. So 3 over 5 would be my sine. 4 over 5 would be my cosine, and 3 over 4 would be my tangent. And I'm hoping you're seeing a little bit of similarity between the two. Okay, let's keep going. So sine of 30. So now they're telling you that 30 degrees is your reference. So OH and A, again, O is across from the angle. It's opposite the angle that we are referencing. H is always H, and the adjacent is the other one. So sine would be opposite over hypotenuse, so 1 over 2. Cosine adjacent over hypotenuse, root 3 over 2. And tangent opposite over adjacent, which is 1 over root 3. But we know that we can't leave it like that. We need to rationalize it. And when we do, we get radical 3 over 3. So that's what goes in for tangent 30. Sine of 60. So now 60 is my reference angle. So for 60, my opposite is root 3 and my adjacent is 1. The hypotenuse stays the same. So I have radical 3 over 2 for sine. I have 1 over 2 for cosine. And I have root 3 over 1 for tangent. I haven't said this yet, but please don't say sin, cos, and tan. It's sine, cosine, and tangent. Those are just abbreviations. So we use this to solve for missing sides and missing angles in right triangles. The first thing you need to be able to do is choose which one, sine, cosine, or tangent, is going to be useful to solve. So in order to do this, you point out your reference angle, and then you label your opposite, your hypotenuse, and your adjacent. So I always go in that order usually. I say, okay, opposite's across from the angle. I know where my hypotenuse is, and then the adjacent's the one left over. Now, to figure out which one you need, you have to figure out what's relevant and what's not. As you can see, we don't even have anything labeled on O. There's nothing there besides the O that I made. With A, I have an X there, so it's relevant to the equation. With H, I have a number 15, and my angle, I have a number 29. So the A and the H and the angle are all relevant. The O isn't. So if we go up here and we look, cosine is the one that does not have the opposite side involved. So cosine is the one that we would be using because it's adjacent over hypotenuse. All right, number 2, my reference angle is 49. 3 is opposite, x is the hypotenuse, and adjacent, I have nothing there. So as I just said, I have nothing on the adjacent, so this would be OH, which if I use SOHCAHTOA is sine. Number 3, my reference angle is 48. I have the opposite, hypotenuse, and adjacent labeled. The hypotenuse is irrelevant because I have nothing there besides the h that I made. That means that this is tangent. Okay, so now we're going to actually solve them. So we're going to use all the information we just said. So we actually figured out, okay, how we're solving these. And we're going to do it. So, SOHCAHTOA. So in number 1, I have cosine. So remember, what SOHCAHTOA stands for are these ratios. Cosine of an angle is equal to the adjacent side over the hypotenuse. So we substitute those values in. The angle always goes next to the trig function. So this says cosine 29 equals x over 15. And with anything, I can put it over 1 and cross multiply. So x times 1 is x, and cosine 29 times 15 is cosine 29 times 15. This is a number. We just have to calculate it. At this point, you need to grab that calculator. So right down here, there's a button that's a trig button. I'm going to zoom in a little bit right there, trig. If you click that, this menu comes up. We would then select cosine, and you would type this in, cosine 29 times 15, and you would get this long number. Those of you who don't like decimals, you're going to have to get over it for this chapter because almost every 99.9% of the equations you are going to do are going to come out with a decimal answer. So you're going to have to get over it. All right. Number 2, we already decided that it was sine. So I'm going to set up my formula. Sine 49 equals 3 over x, opposite over hypotenuse. Again, I can put it over 1, and when I cross multiply, this time I don't have x equals. I have sine 49 times x equals 3 times 1, which is just 3. Remember, sine 49 is a number, so I can just divide by that on both sides. It might look ugly, but it is something you can in fact type into the calculator. 3 divided by sine 49, boom. I'm going to be modeling how to use the calculator in case any of you are worried about that. Don't be, I will show you exactly how in class. And tangent. So tan theta equals opposite over adjacent. We're going to substitute the angle in, substitute the opposite side x over the adjacent 10, cross multiply, and type it into your calculator. There you go. Okay. Now we can also solve for a missing angle. When solving for a missing angle, you still do the exact same thing. So the missing angle is the reference angle in this case. And I have the opposite, the hypotenuse, and the adjacent labeled. I'm hoping you can clearly see that the hypotenuse is irrelevant because we don't have it. And remember what I said, the angle always goes next to the trig function. So in this case, we have tangent of x, because that's what I don't know, equals opposite over adjacent. Now here, whenever you're going to solve for the angle, you're going to use the inverse function. That is whatever function to the -1 that stands for the inverse. If you're confused as to why, I mean, if this was 3x equals 2/3, you guys would know to divide by 3 on both sides. That's because division is the inverse of multiplication. Tangent is a function. So to get rid of it, we have to apply the inverse. So when you do that, I don't know why that just happened, but okay. Real quick technical difficulty. Bum, ba, bum, bum, bum. We were here. Okay. I don't know why it's doing that. Let's try it one more time. Okay, so this is where we were. When you type that into your calculator, you do tan to the -1, and in parentheses, that ratio that you already had. The color scheme has been changed. Well, thank you for that information. All right, so there's another quick rundown. Ooh, okay. So let's try this again. We have the reference angle here. This is the opposite. This is the hypotenuse, and there's our adjacent. We always label those. We have O and A again, so this is going to be tangent. Because I'm solving for the angle, I need to apply the inverse of the function, which I'm doing here, and that is the decimal that I get. Last one, O and H. A is irrelevant. I have nothing there. So I have sine of x equals 15 over 32. And again, you're going to do the inverse of sine this time, not the inverse of tangent. And out pops a number. So that is how you do this stuff. Sorry about the technical difficulties. Have a great day, and I will see you in class.